Hello. My name is Humphrey Solomon Jr. Welcome to my channel. Our today's video presentation is about polynomial functions and graphs. We will also discuss some useful techniques in graphing polynomials. Before we continue, please watch my other tutorials about math lessons, and please subscribe to my channel. Thank you so much. In today's video, I will include the use of Casio Classwiz calculator in finding the zeros or x-intercepts of a polynomial function. Let's start with polynomial functions. The graphs of polynomials are smooth and continuous. That means, the graph has no gaps or holes, no sharp corners or cusps, or pointed end where two curves meet. A polynomial function of degree n, in the variable x, is a function defined by the expression below. Where each ai is a real number, an is not equal to 0, and n is a whole number. An is called the leading coefficient. N is the degree of the polynomial. A0 is called the constant term. Here we have some polynomials of different degrees. The largest exponent of the variable x, within the polynomial, determines the degree of the polynomial function. If the degree is 1, it is called linear function. If the degree is 2, it is called quadratic function. If the degree is 3, it is called cubic function. If the degree is 4, it is called quartic function. We have here an example polynomial function, f of x, is equal to, -3. This function is called, a constant function. Its degree is 0. Because the exponent of x, is 0, which is also equal to 1, and -3 times 1 is still -3. The maximum number of zeros, is 0. Another example of polynomial function, f of x, is equal to, x minus 3. This function is called, a linear function. Its degree is 1. And the maximum number of zeros, is 1. The next polynomial function, f of x, is equal to, x squared, minus 2x, minus 3. This function is called, quadratic function. Its degree is 2. And the maximum number of zeros for a quadratic function, is 2. It means, a certain quadratic can have no real zeros, 1 0, or 2 zeros. The next polynomial function, f of x, is equal to, x cubed, plus 2x squared, minus x, minus 2. This function is called, cubic function. Its degree is 3. And the maximum number of zeros for a cubic function, is 3. It means, a certain cubic can have 1 0, 2 zeros, or 3 zeros. The next polynomial function, f of x, is equal to, x raised to 4, minus 5x squared, plus 4. This function is called, quartic function. Its degree is 4. And the maximum number of zeros for a quartic function, is 4. It means, a certain quartic can have no real zeros, 1 0, 2 zeros, 3 zeros, or 4 zeros. In sketching the graph of a polynomial function, we will need to know: Number 1, the end behavior of the graph of the polynomial function, by using the leading coefficient test. Number 2, the y-intercept of the function. Number 3, the x-intercepts or zeros of the function. And number 4, the multiplicity of the x-intercepts or zeros. Please note, that this technique will not give us the exact graph, but this is a useful approximation. Starting with number 1, what is the y-intercept of a polynomial function? It is the value of y where the function crosses the y-axis. It is where x equals 0. For example, the quartic function f of x is equal to -2x raised to 4 plus x cubed minus 5x squared minus 10 has a y-intercept of -10. Because the value of y at x equals 0 is f of 0 equals to -10. Next, what is the leading coefficient of a polynomial function? The leading coefficient is the coefficient of the first term in a polynomial, when the terms are written in descending order, by degrees. For example, the quartic function f of x is equal to negative 2x raised to 4 plus x cubed minus 5x squared minus 10 has a leading coefficient of negative 2, and the degree is 4. The end behavior of the graph of the polynomial function can be predicted by the leading coefficient test. As x increases or decreases without bound, the graph of the polynomial function eventually rises or falls, depending on the first term of the polynomial. For an odd degree of polynomial, if the leading coefficient is positive, the graph falls to the left and rises to the right. If the leading coefficient is negative, the graph rises to the left and falls to the right. For an even degree of polynomial, if the leading coefficient is positive, the graph rises to the left and to the right. If the leading coefficient is negative, the graph falls to the left and to the right. Let's have an example. We will use the leading coefficient test to determine the end behavior of the graph of f of x equals x cubed plus 3x squared minus x minus 3. We can see that the terms of the polynomial is already arranged in descending order by degrees. This means, our first term is x cubed. It tells us that we have an odd degree of polynomial. And the leading coefficient is positive. So, the end behavior of the graph of the polynomial will fall to the left and will rise to the right. Let's have more exercises in determining the end behavior of the graph of polynomial functions. Here, we will match each function with its graph. F of x will be at letter C, because the first term is positive and the degree is even. So the end behavior will be going on the same direction, upward. G of x will be at letter A, because the first term is negative and the degree is even. So the end behavior will be going on the same direction, downward. H of x will be at letter B, because the first term is positive and the degree is odd. So the end behavior will be going on opposite direction. K of x will be at letter D, because the first term is negative and the degree is odd. So the end behavior will be going on opposite direction. Moving on to x-intercepts. Let's find all the zeros of f of x, equals, negative x raised to 4, plus 4x cubed, minus 4x squared. First is, we equate it to 0. We now have a polynomial equation. Next, we multiply both sides by negative 1 so that our first term will be positive. Then, we factor out x squared. After that, we will factor it completely into x squared, times the quantity, x minus 2 squared. After that, we set each factor equal to 0. Finally, we can have the x-intercepts by getting the square root of both sides. We now have x equals 0, and x equals 2. Notice that we only have two zeros even if the polynomial is quartic. Now, let's try to do this using Casio Classwiz. Our first step is to press the menu and look for equation mode. Second, is to select 2, polynomial. Third, is to select 4, because our given polynomial is quartic. Fourth, we will now input the coefficients of the polynomial function into our calculator. You can follow the string of keys shown. After we input all the numerical coefficients of the polynomial function, we press the equals key. You will see the first x-intercept is 2, and the second is 0. We got the same answers. Now, in terms of multiplicity. If r is a zero of even multiplicity, then the graph touches the x-axis and turns around at that value of r. If r is a zero of odd multiplicity, then the graph crosses the x-axis at that value of r. We can see this better with an example. Find the x-intercepts and multiplicity of f of x, equals the quantity x minus 2 squared, times the quantity x minus 1, times the quantity x plus 1. The graph will look like this. Because, if we multiply and expand this, we will have, f of x, equals, x raised to 4, minus 4x raised to 3, plus 3x squared, plus 4x, minus 4. -4 is the y-intercept of the polynomial. And both ends of the graph goes upward because our first term is positive and the degree is even. Also, the zeros are at -1 0, 1 0, and 2 0. Note that, the graph crossed at -1 0, and 1 0, but touched only at 2 0. Let's check comprehension. Sketch the graph of f of x, equals, the quantity x minus 1 squared, times the quantity x plus 2, times the quantity x plus 1. Let me do a countdown for you. But you may pause this video if you need more time. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, let's multiply and expand this factored form of polynomial function. We have, f of x, equals, x raised to 4, plus x cubed, minus 3x squared, minus x, plus 2. Here, you can see the y-intercept is 2. And our first term is positive, and the degree of the polynomial is even. So, both ends of the graph will go upward. Now, from the factored form of the polynomial, we can get the values of our zeros, -1, -2, and +1. According to the multiplicity of the zeros, 1 has even multiplicity, so the graph touches the x-axis at 1. And -1 and -2 has an odd multiplicity, so the graph crosses at -1 and -2. So our graph will look like this. I hope this video helped you learn about polynomial functions and graphs. Thank you for watching this video. Don't forget to hit the like, share, and subscribe buttons below. Also, click the bell icon to get notified when I upload my next videos. Please share this video with your friends to help them learn more in math. Have a nice day.